We build enterprise software to be predictable and auditable, but the industry is trying to build those rigid systems on top of language models, engines that are inherently non-deterministic. A language model, or LLM, generates text by predicting the next most likely word, based on probabilities, meaning its outputs can vary wildly from run to run. The standard industry fix is to write massive, highly detailed master prompts that try to account for every edge case. But as the context window grows and more data is fed in, the model's adherence to those instructions degrades. You run the exact same prompt twice. The first time, it outputs a clean markdown table. The second time, it invents a new data schema, drops 3 critical fields, and reorganizes the section headers. Treating the language model as the entire application puts a hard ceiling on how reliable and scalable your system can actually be. To get true reliability, the unpredictable reasoning engine must be caged inside rigid, deterministic scaffolding. This requires moving away from isolated prompt engineering. Instead, we have to approach AI development as comprehensive systems architecture. Anthropic recently published a framework of 8 specific design standards for building robust Claude Code skills. Claude Code is an agentic coding tool that executes multi-step terminal workflows. Applying these 8 standards in sequence takes a brittle, unpredictable text generator and converts it into an auditable, multi-agent enterprise pipeline. A monolithic AI script handles extraction, analysis, and generation together. Any minor change risks breaking everything. Layered instruction architecture cleanly divides this into 4 components. The skill document sets global rules, workflow orchestrates steps, templates hold specific AI prompts, and scripts process the deterministic data. To connect these layers, we use the modular data pipeline standard. Scripts do not pass data directly in memory. They communicate with each other exclusively by writing and reading JSON files. JSON, or JavaScript Object Notation, is a standard text-based format for representing structured data. If a localized prompt fails in the template layer, the underlying data extraction pipeline remains perfectly intact and can be rerun instantly. Relying on sequential API calls creates severe bottlenecks in multi-source workflows. An API, or Application Programming Interface, is a set of rules that allows different software applications to communicate with each other. Waiting for a system to ping APIs one after the other is too slow for production environments. This illustrates multi-agent parallelism. Instead of waiting, the system launches independent agent nodes that pull data from separate sources simultaneously. These stateless agents execute independently, depositing isolated JSON data files into separate output directories until the final merge step. This parallel, stateless extraction cuts execution time down to the slowest single API call and physically prevents the cross-contamination of source data before analysis begins. When you ask an AI to write a structured document from scratch, it invents its own section ordering and heading hierarchy. That guarantees formatting drift across different sessions. This wireframe structure uses the script first, AI second standard. A Python script always runs first, building the exact document skeleton and injecting raw JSON data into correct sections. For narrative, the script inserts invisible HTML comments labeled AI Enhance, acting as specific instructions. These HTML comments are highly graphable, meaning they can be easily searched and counted by the system. They act as targeted micro-prompts right where the text belongs. The language model is strictly restricted to providing narrative glue exclusively within those designated markers. It never alters the structural logic. Completely stripping the AI of structural control guarantees 100% format consistency across thousands of execution runs. In an auditable system, evidence discipline is a non-negotiable architectural requirement for compliance, not just a prompting suggestion. The system forces the AI to trace every single generated narrative claim back to an extracted source data point. We enforce specific syntax markers. The AI must acknowledge uncertainty in line, mark data gaps, and actively retract unsupported claims, replacing them with empty brackets. To ensure this works, we use the triplicate rule. It's hard-coded into the skill rules, the workflow step, and the detailed template prompt. A single prompt instruction is easily ignored by an LLM processing a massive context window. Hitting the model with the triplicate rule at load time, at the step level, and at the exact moment of generation is the only reliable defense against data hallucination. Relying purely on abstract text instructions to dictate formatting behaviors has a high failure rate. The AI will interpret those rules differently every time. The solution is example-driven learning. The system feeds the AI 2 to 6 exact match reference documents to establish strict pattern recognition before generation begins. If those reference files are missing headings or contain errors, the AI will perfectly learn and replicate those structural inconsistencies. The examples must be flawless. Even with perfect internal formatting, workflows are fragile due to external factors, like sudden API endpoint changes or rate limits. The self-healing standard handles these external script failures autonomously, eliminating the need for human intervention. When an error occurs, the system triggers an automated recovery loop. It logs the precise issue, patches the Python extraction script during the live session, and automatically retries the execution. True system autonomy is achieved when the pipeline can rewrite and repair its own deterministic extraction scripts the moment the external data environment shifts. At the conclusion of a long, multi-agent AI workflow, users are often left with operational blindness. They don't know what was produced, how complete it is, or what needs their attention. This dashboard represents the structured output standard, mandating a fixed completion summary table at the end of every workflow. It includes file locations, key metrics, a trust disclaimer, next steps, and exactly how many data gaps the system identified. Long-term operational trust is built by explicitly showing the user what was generated, what failed, and exactly what source data was missing. The complete engineered pipeline functions as a single unified system, parallel extractors feeding raw JSON data directly into a deterministic script-generated skeleton. The language model's final role is highly constrained. It acts solely as a narrative enhancer, strictly guided by triplicate rules and concrete reference examples. Like fluid forced through unbreakable conduits, structural drift is eliminated by isolating data, hard-coding the structure, and enforcing strict evidence markers. Escaping the limitations of non-deterministic AI requires elevating our practice. We must move beyond prompt engineering and commit to rigorous, predictable systems architecture.